Well, for those of you who've been following my channel, I've been in the process of building and designing a CNC machine. It's under Canadian CNC build playlist. Anyways, one of the hardest or the greatest challenge for me was sizing stepper motors for my application. And I found this neat software that actually allows you to put in what your machine is made of, like ball screws, size of ball screw, dimensions, and then it actually calculates the torque for you. So the first thing that you need to size stepper motor is torque. So I'll show you how to get this. So we'll just get the internet going here. It's actually from Bosch Rexroth. So we're going to search Rexroth. It's called IndraSize. So we'll see what comes up here. It's probably the first one. There's a German site and American site, does not matter. And this is free software too, by the way. Get in here, look, ball screws, rack and pinion, belt and pulley, rotary, all sorts of stuff. So here it is. Just click this. I'm not going to go through the install. It comes in a zip file, so just unload it. And it's on your desktop. Anyway, so let's start a project. This is the main screen when you open it up. Select your language or whatever. Start project. Here is the project. You can create a new one, open, save as, load drive, export to Excel, print, all that good stuff. What we're going to do is drive sizing. And my particular application is ball screw. And I want to choose ball screw, rotating ball screw. So now immediately this comes up over here, which is a standard linear motion. There's flying cutoff, which is a shearing on the fly, but we're just doing standard linear motion. And here you can choose rack and pinion as well, or ball screw nut, rotating nut. So I click next. First you'll get, this is like an input screen. My drive, this is a picture of your stepper or servo driver connected right to the ball screw. I actually have a coupling in there, so I'm going to insert that. You can also insert a gearbox too if you want, and notice as soon as I inserted the coupling over here on the input side, it says input data for coupling 1. See here, if I go input data for gearbox 1, and I don't have a gearbox, so I can go back and I'm going to delete that element. Okay. So my moving weight for my gantry, for those of you who've seen my video part 1 of the design of the Canadian CNC build, my gantry is about 60 pounds. Ball screw lead, I have a 5mm ball screw lead. My moment of inertia spindle, none of us are going to know that. So you click this little calculator here, and look, you just punch in the specifications of your ball screw. For my case, my ball screw outer diameter was 20mm. The length was 1,150 millimeters, and the density. Well, I don't know what the density. Well, click the little calculator. And steel, cast iron, brass, copper, aluminum, I'm steel. So I'll click apply, and there, data's right in there. Efficiency, ball screws are about 92. I'll just put 90 for fun. Coefficient of friction, don't know that. Click the calculator. Sliding friction steel on steel grease, I have runner blocks, so that's what it'll be. Click apply. Additional force, I don't have any additional forces. Additional torque. This I would say the amount needed to actually cut wood. So I'm going to say 25 Newton meters. Now this is another interesting thing. If you're on a slope, for example, your z-axis is 90 degrees, you'd put in 90 degrees here if you're doing a z-axis. Next for my coupling, I'll just put name, coupling. Moment of inertia, no idea. Oh, look, check it out. My diameter is inch 1, length is inch 1.5, distance A. For some reason, I don't know why the software needs that. I don't know what it is, but I'm just going to say 0.5 inch. Like, could be radius, or I have no idea what that means there. Calculate cylinder, and look, it's just so small. Apply total inertia. Oh, didn't do it. Go back in. Saves what you had. So apply inertia. There we go. Now it's there. Everything else is just the data needed for this motor. So this is actually set up for Bosch Rexroth motors. So it's going to give you a selection of Bosch Rexroth servo motors to choose, where I just need the torque. So this is like you can make a simulation of what you're going to do. So you can do a motion phase. If you do acceleration, you can do constant velocity, deceleration, dwell, which is just pausing, or off. So this is if you want to make a custom configuration, and you need two parameters, distance, time. You can check these boxes if you have acceleration, speed, etc. But what I'm going to do is a trapezoid 1/3, which it's going to make a trapezoidal pattern. So 1/3 is acceleration, 1/3 is constant, and 1/3 is deceleration. You also have a triangle, which is acceleration, deceleration, whereas this has the constant in there. The distance I want to travel is 1,000. I'll make it the length of my ball screw, and I want to do that. So here you can actually put in the time, so your feed rate, what you want to do, like what you want your machine to run at in millimeters per second, inch per second, kilometers, all sorts of stuff. So I want to say I can do that in 8 seconds. Feed force, 0. Additional mass. I'm going to put my router on there, so maybe 7 pounds. Now what we do is you just insert, and bam, look at that. Right now it tells us our average speed, just over 1,700 RPMs. Maximum speed to get up there, 2,500 RPM. Effective torque, 25 Newton meters. Maximum torque, 25 Newton meters. Now this is the key right here. So our effective is more or less our continuous, and maximum is our peak. And then here's more inertia. Now, you can see here on the graph, here's the trapezoid I'm talking about, which is the speed, so acceleration, dwell, deceleration, or constant, I mean. Here's acceleration, and then distance traveled. And this is a neat little graph to show you. And for some reason, my effective torque is really high. So I'm going to change this value to 10, and you can refresh it. Still very high. Additional mass, put this to 0, refresh. Back. Oh, additional torque. There's because this is extremely high. Next. See here, look, it automatically updates it. So it's saying 0.04, which is very small. Oh, additional force, that's where I put the 25 Newton meters. There we go. Refresh. Look at this, 0.06 Newton meters, not much at all. So if we go back and we type Newton meter to ounce inch, conversion, go to our first converter here, Newton meter, go to 0.07, convert, only 9.91 ounce inch, not very big at all. So you can see right away the torque multiplication that that ball screw is actually doing to the system. Like, it's insane. And if you watch some of my videos, I actually hook my drill up to it, and it's very hard for me to stop the gantry from moving just from the torque multiplication. So hope you like this little neat trick. Certainly helped me out, and hopefully it'll help you size your stepper motors. Till then, see you next time.